Okay, it's time to start. Let's not wait. Welcome everybody. You're in Secdispatch working group meeting, IETF 107 virtual meeting. So if you could go to the first slide, please. So just a reminder that this meeting is recorded. See.
Francesco, which slide would you like to be on?
The first one. So just to remind everybody to turn off the video and also your microphone unless you're speaking. Use WebEx chat to join the mic queue and only to join the mic queue. Any other conversation, please move it to the Jabber. Plus Q to I will add you to the queue and minus Q to remove you. Please remember to sign your name and affiliation in the Etherpad. The link is there. Also, Kathleen posted it. And yes, please do join the Jabber room. I also want to ask you to state your name before speaking, even though Kathleen will be introducing you. And if you can speak, feel free to use the Jabber room and with mic, and your comment will be reported via audio. We are looking at the Jabber chat, so if you use +1 in the Jabber chat, please make sure to write down what your +1 is for, so that we can keep track. But also, let's try to keep the what you think is important conversation in the microphone, so that also the presenter doesn't miss what's being said in the Jabber chat. But if you have clarification questions, of course, you can post them there. Also, let's try to make the discussion at the end of the presentation. This will hopefully help the presenters to go through the presentation in a shorter time. And for the speakers today, we were thinking, if you can, to keep the presentation 10, 15 minutes and the rest for the discussion. That would be great. And next slide. So yes, this is an IETF meeting and the note well applies. Please take the time to read and understand the IETF rules, and in particular those about IPRs and disclosure. Next slide. Yes, we are in Secdispatch. Next slide. Here is a bunch of useful links that are also posted everywhere by now. Next. Yes, we have a new wiki. So we started to set up this Secdispatch wiki. This is just a place to just to help out to have a useful discussion. So there are guidelines for effective participation in the Secdispatch working group. This is mostly for people who are not aware of how dispatch working group works, but it may be good to have some form of template also for asking for a presentation slot in one place. So please take a look, and if you have some feedback and comments or something that you might want to add there, please let the chairs know, or also feel free to edit yourself. Yes, next slide. The dispatch process. So this is a dispatch working group. So this working group does not adopt drafts. It recommends next steps for new work. So these are the possible outcomes. So directing to an existing working group, propose a new working group, AD sponsorship, IETF should not work on this topic, or additional discussion is required. So please keep these outcomes in mind when you listen to our presenters today, and when you ask for questions. Next slide. So here is the agenda for today. So we are in the first slot. We are in the intro right now. Then we have Stefan presenting SVT. Then Brian will talk about client certificate HTTP header. And Kirsty will talk about IOC and the role in attack defense. And finally, Rick will present adding SASL to HTTP. Is there any agenda bashes before we start?
Looks like Roman, didn't you have one?
Oh, go ahead, Roman.
Hi, I just wanted, this is Roman. I just wanted to go back to where you were talking about the wiki and kind of thank you and the other kind of co-chairs for putting that up. I think it's really critical for us as the IETF to make it easy to find the right entryway to get work started or to talk about work. And while I appreciate that some of the content there is, like you said, not targeted at folks that know how the process works, I think it really will help folks that are a little less familiar with that process. So again, really +1. Thank you for doing that. I think it's quite helpful.
Thank you, Roman. Yes, and I should also mention that right now that is linked from the data tracker page, the Secdispatch data tracker page, and I've also posted it in the mailing list. Yeah, thank you, Roman. So if there is no comments on the agenda, I think we can start and go ahead with the first presentation.
Finishing the intros and starting, and there are 124 people on the WebEx.
And we can hear you, Ira. So you should mute yourself.
Sorry.
No problem.
Sorry, give me 1 minute to get the slides up.
No, you should. We are early, so take your time.
All right, we should be ready to go. Stefan?
Okay, thank you. Stefan Santosson is my name, and I'm here to present the signature validation token, which and offer that as an input to the IETF process, which I personally think is a very, very exciting topic. And the basic idea behind this was initiated or started more than 10 years ago when ETSI tried to address the long-term signature validation in what I found was a very backwards manner that I think was doomed to fail, and it still has not succeeded. And until now, many people haven't cared about the long-term validation, and I have to say that most of the time I have been one of them. But recently, this has become a very, very important topic. You can move to the next slide. So this is all about being able to validate signatures in a distant future. Can you switch to the next slide? Slide, please, if it's possible. So the goal is to have a very, very simple solution instead of a very complex solution for validating signatures in a distant future. And recently, this has become a very, very focused topic, especially in government agencies, where their legal departments are pressuring them in order to make full use of electronic signed documents in favor of, instead of having paper-based signed documents. And many agencies find themselves in a void with no mature standards and develop services to rely on. And they are forced to invent their own solutions. Many times it's just about having some kind of log that this document was actually, with this number, actually was verified and signed, and that's all they have. But there is a pressure in order to get something that works, but the complexity of current solutions is a big deployment blocker. Next slide, please. So in order to talk about history, we have always sort of approached the problem like the time machine approach. And that is to, we have defined the standard so that we can do the validation in current time. And in order to do that validation in current time in the future, we have to build a time machine that brings us back to a moment in time where the signature was fresh, the certificates were trusted, and the algorithms were secure. Go to the next slide. So there are three things that you want to achieve in order to do that time machine. One is to establish a time when the signature actually existed, where all of these checks can actually be done. That means in that time you can prove that the certificates were valid. And you can also prove that the document you're looking at right now is matching the signature that existed at that time. And at this time, the algorithms in use were still considered secure. And it's important that you have actually, you need to prove that that document you're looking at is that document that was covered by the signature, because if you're looking at the time when the algorithms are no longer secure, you may present another document that you found in recent time that would match the old signature, and you can fool the system that other way. So next slide, please. To do this trick turns out to be a very, very complex thing. And this is a very much simplified picture. First of all, we have the certificates that support the signature. In order to prove that they were valid at the time, you need to have stored revocation data, such as OCSP serial responses. So OCSP responses and revocation lists. In some countries, you actually have national OCSPs, not the one that are signed directly by the CEA issuing the cert, but a national OCSP responder supported by its own cert chain, which can make things very, very complex and hard to validate in the future. To prove the time, there is normally a timestamp of the signature itself. And then in order to prove that the document existed, you do the archive timestamping. That's the timestamp to the left. And all of this needs to be supported by certificates. And then you may have many cascade of archive timestamps when the certificates supporting the first time expires, you need a new one and such. And you may also have a document with many signatures, and this multiply all the time. In the worst case scenario, failing to validate or prove the validity of one of these signed objects fail the whole chain of proof. Next slide. So the obvious problems of the time machine approach is that it's very, very complex. None of the timestamp services actually do any validation of the signature itself. It's all designed to bring you to the point where you can validate the original signature. The current standards are incomplete. For example, there is no requirement to store certificates supporting revocation data. It's voluntary, and you may actually need that data in order to prove the full chain of evidence. Eventually, a proof of this time will crumble under its own weight and will be impossible to uphold in the future. At some point in the future, it will be too complex to do that validation with any certainty. Next slide. So the idea here is that we need a new paradigm. We need to do this much, much simpler. And next slide. There are three basic ideas in order to achieve this. First of all, to remove the time machine. So the idea is to have a token that does not do a time machine trick, but actually is an assertion that the signature was checked according to a certain policy when the signature was fresh. And this token can be signed with a secure algorithm that survives beyond the certificate validity period. So it would remove also the need to validate any of the original cryptographic primitives. So the original signature algorithms and original hash algorithms do not have to be used anymore once you have the SVT. The third thing is that you achieve this by one signed statement, the SVT itself, signed by one currently trusted key and using one current trusted algorithm. And when in the future an SVT might become old, you can replace it with a new one. So next slide. So this looks quite easily, a quite simple structure. So we have a typical signed documents which have a signature. The signature contains some kind of signature context with this, which is a excerpt of what is signed and the hash over the signed data, what algorithms are used and transforms and so forth. Then there is a signature value actually computed over the signature context. And then there is a certificate supporting the signature. So in the signature validation token, which is a JSON web token with claims, there are hashes over the signed document. There is hash over the signature context. There is a hash over the signature value. And there is a hash over the certificates used to do the verification. Because of those hashes, you don't have to use the crypto algorithms of the original signature once you have the statement. It includes a statement about verified times that were checked and statements about validation results that was done by a trusted validation service. So this is like you do the validation by a trusted service once, and then you store that validation result in the token, and you no more have to validate the original signature. Next slide. This can be do very, very small and very, very efficient. This is a, well, I made the hash values a little bit shorter for a good presentation, but this is actually a complete claim set of a signature validation token. It contains the time of issue and the issuer, and it has a claims about one signature, and that's pretty much all it is. Next slide. We have basically two profiles, but suggestion also possibly a third one for how to do this in PDF documents and XML signatures. In the PDF document case, where the next signature covers the old signature and makes it complex to add data to previous signatures, we suggest to add a document timestamp where the signature validation token, the SVT, is just an extension inside the timestamp. And we have running code. This works perfectly fine with no problems. In XML, the signatures are more atomic and can live by themselves, and we would suggest to include the signature validation token in an object inside the signature itself, and as it's unsigned data. We would also think that it was much possible to do this in a JVS document, JVS signature, as an unprotected header. That's up to discussion. Next slide. It's important to remember that the SVT token does not claim that the signature is valid. It only claims that the trust service A performed the valid process B to validate the signature and came to the conclusion C. And the important difference is that that claim never changes. The fact that A did the validation process B and came up with the result C is true whatever happens in the future. While signature validity can be something that we can change in the future. So that we are aiming at making a signed statement of something that will never change in the future. That's something we can always say, once you have issued the statement, that statement will never be false. It never has to be expired or have any expiration date, actually. It can be valid for as long as the cryptographic algorithms can support it. Next slide. Some of the criticisms we have had in the discussions with external parties is some people have a hard time to believe how I could trust a token, SVT token. What if the verifier is not trusted and so forth? And our counter claim here is that you are even worse out with a traditional time machine approach, because in the traditional time machine you have to trust statements from many trust services. And if one of them is false, your chain of proof falls. Here you have one trusted service doing a trustworthy validation process when the evidence is fresh, and that is better evidence to the judge than coming up with all of this complex collection of signed objects. So what if the SVT gets too old we see no problems of issuing a new SVT based on an old one. You can simply replace it. Some people say it's obviously better to be able to validate the original signature than to rely on a statement that it was valid. We have run this through lawyers, and I think that that is, if you look closely into the proof, is very much easier to present the evidence that a trusted third-party service who made the validation of the service is a better evidence than trying to come up with complex chains of proof. Next slide. Why would I trust your validation service? It's also important that it is not the signer typically that adds the SVT. It is the relying party. After receiving the document, verifying the document, and wanting to archive its own evidence, is going to turn to the SVT issuer its self-trust, and then add it to the document after the signature was created. So it's not about I create my SVT and everybody needs to trust the one that the signer provided. It's the relying party, the verifier typically, that adds this. Do I have to use special tools in order to make this document work? No. The solutions we have for PDF and XML will work with any standard XML process and any standard PDF. Any standard PDF reader will just see this as a document timestamp and will see no strange things with it. Any applications who actually understand this can take it a bit further and use it as a validation tool. So next slide. So the status is that this is a government-funded research project in Sweden right now, but it's more than actually a research project. It's actually also developing a document that will be considered as a Swedish standard for government agencies. Specifications are available on GitHub, and we are creating open source, and we actually right now have running code for PDF and XML and Java. And open source for production-ready open source will be available, and it's funded to be developed and available at latest in September this year. Next slide. So why IETF? Well, I think, first of all, it's based on the JOT formats. Maybe that's a bad argument, but it can support IETF signature formats like CMS and JVS. There are actually no other standards organization that is doing this, and IETF have done similar work in the past. If we're looking at evidence records and such things with LTANs, I don't know if that's a good argument either, but it is a very important subject, and this solution is maybe simple enough to be a nice thing to make into a standards document, and it would be a good thing to have at least something standardized that can be a counterbalance to the time machine approach, which I think is destined to die under its own complexity sooner or later. Next slide. Where would I like to see this? The only group existing I can think of is LAMPS. So I have no other proposal than that. Maybe it fits, maybe it doesn't. That would be very good to have your inputs. And that was my last slide, and it's open for questions and comments.
Great. We have one of our ADs, Ben Kaduk, up first.
Hi, this is Ben Kaduk. So I found it kind of interesting that at the start of the presentation, you talked about being able to, in the future, validate a signature, and then we sort of transitioned in the latter half of the talk to the SVT proposal, which is more about knowing in the future that the signature was valid now. And I think these are related concepts, but they're slightly different, and they have slightly different semantics. So I think it's unclear whether we should be doing this work until we know what the actual requirements are for the people who would be using this. If they're more concerned about knowing in the future that the signature is in fact still a valid signature issued at that original time, or if they only need to know that the signature was valid at the time it was made, or at the time that the SVT was made. And with my apologies to the people behind me in the queue, but Mike Bishop had mentioned in the Jabber a very interesting point that I will repeat on his behalf, which is that if we treat this not as a proof that the signature is good, but we are instead like making a note to ourselves or a note to people that trust ourselves that we have checked the signature, that's sort of yet a third different semantics that we could be assigning, and that might actually be more palatable to be able to reason about.
Well, that's a very interesting comment, and the first time I've heard it in that way. And you're absolutely true in that sense that we are making a statement that we actually performed a validation process, which is not very different from having a revocation statement or an OCSP statement, because that is also a statement of the validity of some of the proofs here. But we do have the hashes over all the signature elements in order to prove that they are accurate. And we have a statement that the signature itself has been validated, and you can also check the crypto primitives if you want to, using the old algorithms. So the idea is, of course, to establish the fact that the signature was valid and is valid. As the lawyer we are talking to stated to us, every signature is valid once signed. They never become invalid as long as it can be proven that they were valid, and at the time when they were written, they never become invalid.
Okay, so I guess in at least that particular legal case, the two sort of distinctions I was making are collapsing into being equivalent.
I would think so, but I'm not. I would think so, yes.
Okay, I was just sort of going at this from an example that was also mentioned in the Jabber room about, like, if I have the title to a house or the deed to a house, you know, and I go to sell the house in 20 years, what is the actual property that I need? Do I need the signature on that, the deed to be valid while I'm selling it? Sort of intuitively seems like the key property to have. But if from a legal perspective, that's equivalent to the signature having been valid in the past, then maybe there's not a problem.
No, this turns into more a legal than a technical discussion. I'm not a lawyer, but all the lawyers we're talking to claims that the signature never becomes invalid. It may be the fact that you bring new proof to the table that the signature was never in fact valid, and it was never in fact signed by the person who claimed, and I can bring those evidence, but you can never come to a conclusion that it was valid when signed, but some mysterious way it became invalid. So the only thing I have to prove is the fact that the signature was validated successfully at a certain point in time, and that makes it valid forever.
Okay, yeah, because I guess from the legal perspective, that's a different way of thinking about signatures than we're used to in cryptography for protocols.
Yes. So this is like a way of supporting the fact that the signature was checked during all of the evidence that were available at the time, and it was actually validly signed by this person. And these were the things that we checked, and you can add all of those data into it if you want, but the most important thing is the conclusion, which is a lot better than a lot of government agencies are doing today, because they just have a log with a number reference to the document with no cryptographic integrity of the document whatsoever.
Right. Okay, well, let's move on to Ecker's question.
Hey, Eric Rescorla.
Hi, Eric Rescorla. I guess my question, so as I understand it, the design here is intended to protect against, in part against compromise of the key material of the you just signed the original message, right?
Say the last thing once more.
In part, this is intended to protect against compromise the key material used to sign the original message, right? Or the algorithms.
Yes, that's part of it, because if the original algorithms become broken, it becomes so much harder to validate the original signature, and it requires so much supporting evidence.
Right. What about compromise of the algorithms used to sign the SVT?
Then you have to, before they got compromised, issue a new SVT or protected by blockchaining or any other method that makes the compromise non-feasible to exploit.
Right. So I guess what I'm trying to figure out is, doesn't that seem like, aren't we back to the same problem we had before, reconstructing the state?
You would believe that is the case, but I claim no, because in the original case, you still need to validate the original signature. So you need the whole chain of proof to go back to the time where you actually could validate it, prove that this was the date I did validate, and so forth. In this case, we have a statement that the validation process took place, so I can replace the SVT completely with a new one. I don't even have to save the old one. So the new SVT will replace the old one, and you don't have the cascading complexity here.
I'm going to have to step it down. I'm not persuaded.
I understand. I had to think about it for a long time, but that's my conclusion today, and I understand it's not easy to sell. But if we sit down, I think I might be able to persuade you that you could do this trick without creating the cascading complexity. But
sounds good. Thanks.
Yes.
Okay, next up is Roman Danilo.
So before we move on, just to say that clarification questions are great. Thank you for bringing those up. But also, please, let's try to remember that we are asking for feedback on the dispatch questions. So those are very appreciated.
The blockchain came up right away there. Well, this is not a blockchain proposal, I promise you.
Roman?
Hi. Hi. I wanted to get a better sense of how much work there is here. I mean, kind of hearing you kind of talk through it, there's the core underlying kind of approaches, and then it seemed like there are a bunch of profiles that would need to be made. Am I reading that correctly?
Yeah, there is a basic standard or specification for the token itself, but you need to profile how you include the token in every type of signed document like PDF and XML, and for each type of signed document you need a profile, and so that's correct. Yes.
Got it. So with that intuition into what Francesca just said, I think since you had lamps up there, this seems like a more substantial body of work. I don't know whether we could easily jam that in there.
I fully understand that you come into this profiling issue where you want to stick the profile. You could have, it could be something, in my thought, it could be something like you see in which is no longer active, but the token. I lose the word, but the protected token, bearer token, that is in other standards as well. You might have the basic profiles in one group, and you might have the other profiles in other groups if the need arises.
Okay, next up we have, and I'm cutting the queue just for time considerations. We have Ben Schwartz.
Hi, Ben Schwartz. So if I am the I think TSA, we called it, and somebody comes to me with an RSA 512 signature from 1998, what am I supposed to do with it?
If you can't verify it, you can't issue an SVT for it. The idea with issuing an SVT is to do it when the evidence is fresh and trustworthy. And that clearly does not seem like a trustworthy signature to me.
Okay, so the TSA has some kind of policy.
Yeah, exactly. The standard itself does not claim or enforce any policy. It just gives a blank sheet for you to say, I did the validation according to this policy, and this was the conclusion. And if you have a policy, a very low-level policy, that we did this validation of this very insecure signature, we came to this conclusion, you can do that. But the point of doing that is sort of very small.
Okay. I think that's clear enough. Thanks.
Okay, so I think that there was a
Richard
question.
Farms.
Okay.
Sorry, Farms in the queue, and then that's it.
I just have one quick question. Stefan, it seems like In the use cases you described, this was mainly the same entity producing and consuming the SBT, which kind of hints to me that this may not need a specification. So what I'm wondering is, why is there a need for an interoperability specification here? Are there multiple vendors seeking to do this or something like that?
Yeah, in the simplest of cases, you actually don't need any standard at all, or not even agreement if you do your own implementation. First of all, we may want to foster to have off-the-shelf solutions that can be handed over with limited price tag, and that would be supported by standards. But you may also, in a community, want to be able to verify each other's SVT tokens, so that you can increase the size of the community that would benefit from the same tokens. So, but it's a fair and valid question.
Okay, so we have one question from Jabber, if we can make it really quick as we are out of time.
Sorry, is there time or is there not?
Yes, really quick.
Right, so the question is there a reason that this needs to be embedded in a document and can't just travel alongside the document, as that would change the dispatch questions a lot?
It can travel alongside the document. It does not have to be inside the document. It was an important feature in our project to be able to put it into the document for several reasons, but it's definitely not necessary.
Okay, thank you for that. So to wrap this up, so the chairs have chatted and we think that more discussion is needed, but we would like to hear what our ADs have to say. So Ben, Roman.
Sorry, unmuted. Yeah, I was tricking me a little bit to unmute. Yeah, I concur that we need more discussion here. I don't see an obvious place with an existing working group. Perhaps we could suggest, if there's interest, we could start up a mailing list to get more discussion on what it is that we're talking about here. If it turns out that the scope of work is as broad as it seems here, that seems like BOF might be next step, but I think we need a lot more discussion on it.
Anything else you want to add, Richard and Kathleen?
I agree, more discussion would be useful. Thank you. It was a good presentation.
Yeah, I think in your dispatch process slides, one of the outcomes was more discussion and community building needed. I would be interested to see the community of interested folks here.
Okay, thank you, Stefan, for the presentation. And we can move to the next, Brian.
Thank you. Let me the
slide should be up now.
Should I share mine, or are you gonna do?
So Brian, I have the PDF that was in the materials. I'm ready to drive that if you like, or you can drive it off yours.
These are my slides, Rick.
Oh, yeah. Why don't I take it then, and hopefully drive it from sharing mine.
Yep, go ahead.
Thanks, Richard. Maybe. Is that showing up on the other end of the clouds there?
Yep, shows up for me. Thank you.
Okay, thank you. Thanks, Secdispatch, for having me today. I'm going to talk about a modest proposal here for a client cert HTTP header. The idea is basically to convey client certificate information from a TLS terminating reverse proxy from there to origin server applications on the back end. And some of you that know me probably know my penchant for putting photographs in presentations here. So even though we're not in Vancouver, I thought I would include a little shot of Vancouver here just as background for this presentation. And I promise that somewhere less than half of these slides have gratuitous photos in them. So going forward with that, talk about what this is a little bit. Try to get at the sort of problem statement here. And that is that basically a lot of HTTPS application deployments have TLS terminated, at least the initial TLS connection terminated by some kind of reverse proxy somewhere in front of the actual HTTPS applications that are doing the work. You see this in a lot of different ways, the old-fashioned kind of in-tier reverse proxy and origin server architecture. More and more you're seeing like CDN as a service type offerings or application load balancing offering services that do the same thing. They're effectively terminating TLS and proxying the traffic back to the actual application, sometimes even in a different domain of ownership. And even more so, or lately with things like ingress controllers in your new hotness of the microservices world. And sometimes TLS client certificate authentication is used. I know it's not super common, but it does happen sometimes in certain use cases. And in that case, it's often the needs of the actual backend application to know something about the client certificate. What these needs are will vary, but usually it needs to know something about it to do something, act on the authentication, log the data, whatever it is. And in the absence of some standardized method of conveying that client certificate from the proxy to the backend applications, different implementations have done it differently, or in some cases not at all. And this is the case of things right now. You'll see in systems like Apache, there's some de facto ways to do this with some recommended header names and things in Nginx, but there's nothing that's common beyond just sort of the general idea of how to do it. The actual names, header names, and how data is encoded vary from system to system, or in a lot of cases, something like this just isn't supported at all. So wrote a draft over the last couple of months trying to basically standardize on what a header would look like that would allow the reverse proxy to convey the client certificate from itself to the backend application, so the application would have the data it needed to work on it. And rather than going into the details of that, tried to draw up a basic little picture to show what it is. The idea here is this would be a simple idea that could potentially enable like turnkey style interoperable integration between independently developed components. And how this would work is you have a client making a call to the server over HTTP over a client certificate mutually authenticated TLS connection. And the client has no idea what the architecture of the backend is. It's just making a call to the proxy and sees that as the actual server itself. The proxy sanitizes its headers and will then pass the client certificate as a new header with a defined name and encoding along to the origin server. And the origin server then can do whatever its application specific needs with that certificate are. And that's like all of it in a nutshell. There's not that much more to it. Certainly specifics that could be worked through, but that's the main idea, is just conveying that certificate from the reverse proxy to the origin server through a known, well-known, defined, standardized header, name, and encoding. A little bit of backstory about how we got here. I was one of the co-authors on RFC 8705, which was about using mutual TLS client authentication in conjunction with some OAuth functionality. The details of it aren't really important to this, but through the course of discussing that and some other things on the mailing list, one participant commented that he thought that this particular problem of how to deploy these sorts of things with an architecture like one that includes a terminating reverse proxy was undefined and difficult, and that it was a shortcoming of this particular specification that it didn't define it itself. Sort of paraphrasing my own thoughts there was like, well, that's really beyond the scope of that, although it's a potential problem and something that can be improved upon. Certainly doesn't belong in the scope of that particular document, which is just about using mutual TLS and OAuth specifically. But some more conversation passed, and basically the question came up, well, is it possible to define something like this and maybe get it pushed out into HTTP or TLS working groups? It'd be more appropriate there, and actually be very helpful to have this as a general specification. Following up from that, one of the SecADs suggested maybe looking at hot RFC or Secdispatch. this was leading up to the Singapore meeting, and I wasn't going to be there in time to do hot RFC, so I begged for a Secdispatch spot, and some of you may remember me from the very end of that, where due to not having a draft at all, and a little bit of jet lag and trying to rush the presentation in the last 5 minutes of the meeting, and sometimes with slides that had way too many words, the consensus there out of the Secdispatch meeting at 106 was basically, please come back later with an actual draft. So that's why I'm here. Yeah, so following on that, basically I wrote some drafts, shared them here in Secdispatch. Thinking about it more, maybe this should have been a more general dispatch thing, but we got here how we got here. And the draft itself has received some positive, if somewhat underwhelming reception. Here's just a few quotes. Somebody said it was useful. Some people support the effort, and the lack of it has been a pain point, migrating applications with client-server-driven mechanisms to the cloud. Off list, somebody said, good luck on the effort. If you need a vote, please let me know. Strangely enough, this is somebody that works in the IETF and knows we don't vote, but he mentioned that anyway. Someone went so far as to say, I was surprised it wasn't already a thing already. I can't see why it would be any other place than an HTTP. And also off list, a coworker of mine mentioned that would have been really useful to have, although he said it would have been nice 2 years ago since we've already done some integration like this without a standard. So there seems to be interest in it. If, like I said, somewhat underwhelming, there hasn't been a lot of response, but largely everything that's been said has been at least mildly positive. There was some more technical feedback that came through just slightly before this meeting I haven't had a chance to fully look at, but I think some bits of it may be covered or at least discussed further in the presentation. Despite that, I have my own trepidation about the work, or at least proceeding with it. You know, there are lots of disparate solutions already out in the market that exist for doing this, and retroactive adoption of late coming standards like this is really uncertain at best. When things are already working, sort of trying to retrofit a standard to replace existing ad hoc solutions is often ignored or not well received, or just doesn't get a lot of uptake. I'm also a little worried that despite what seems like a pretty simple proposal, consensus here might prove surprisingly elusive. The thread I mentioned previously on OAuth that sort of led to me doing this work, after that consensus was sort of considered the work elsewhere, the whole thing degenerated into really strong opinions about how to properly secure or not the communication between the proxy and the backend, and even got into borderline personal attacks, which isn't really relevant, but it seems people have a lot of strong feelings about this sort of thing. At a previous IETF, I was attacked, although it was not personal. I was attacked in a meeting by an AD when discussing a very similar proposal around conveying this kind of information with respect to token binding. There's likely to be contention about exactly what pieces of the certificate and how much of the certificate and or certificate chain actually get conveyed. I know some people have felt like something like this would be more proper inside of the framework offered by the forwarded HTTP extension, but that brings its own complications. There's similar-ish type of work going on, but at different layers. So it's not a direct analogy, but that it also is somewhat competitive to this sort of thing. And frankly, there's all the other things that I don't know about. And the one I guess I do know that I don't know about here, I mentioned, is the secondary certificate authentication in HTTP2 that would at least potentially have some ramification against something like this and what actual data goes in there. So while there's the potential for something like this to be really useful, there may be difficulty in actually getting to a consensus approach. And even if we did, there's some questions about whether it would actually be useful at this point, since there's already a lot of people already doing something similar, just not in a standardized fashion. And I don't know. I'm sort of on the fence about it, obviously, which is why I have both sides of the argument up here. And so kind of looking ahead, an opportunity to sneak one more photo on here. I hope we actually do get to go to Bangkok, but even that may not happen. But I'm here at Secdispatch to try to get a sense of whether to dispatch this or not, and if so, where would be the most appropriate place for the work. TLS or HTTP seem like potentially obvious is maybe the wrong word, but potential candidates, or maybe somewhere else, and then honestly, not at all is not an entirely unexpected answer either. With that, that's all I've got here. So thanks for listening, and take it to
Thank you, Brian.
back to the chairs.
Thank you, Brian. You got a lot of people in the queue. And before we start with the queue, just wanted to just highlight what you just said. So this seems like the options, also considering the positive feedback we've seen, the options might be HTTP BIS, TLS, or a focused working group, or maybe something else. So please, whoever is on the mic, please think about these possible options when you comment. Thank you.
We have 9 minutes for this part of the session. With that, Mike Bishop, you're up first.
Mike Bishop. So first off, from the secondary search standpoint, there's no conflict with this because secondary search is intended for delivering the cert to that first terminating resolver in the first place, whereas this is for the back end. So no conflict there. Use case wise, I really like this because it lets you pass things to the back end. Ironically, it feels very similar use case to the previous presentation in that you want an attestation that, yes, I have validated this signature. And semantically the same, we're just not looking to do it 20 years from now, we're looking to do it one hop further down the line. As far as where to locate it, probably HTTP, but I can see reasonable arguments for putting it in the other places. Thank you.
Thank you. I'm not sure I have any response or that one's even needed, but appreciate the feedback.
Okay, so Nick Sullivan.
Hi, Brian. Thanks for the presentation. I'd like to just first say that I support this work, and wherever it happens, Cloudflare is very interested in implementing it. You had mentioned that this is potentially a retrofit. I would say from our perspective, it hasn't been implemented yet, and this solves a need. So I'm very much in favor of finding a home for this.
Okay, thank you. Yeah, I mean, it would be a retrofit for some environments, but it's encouraging to hear that, that it could be useful as a new piece going forward. So thank you.
Mark Nottingham.
Hi. I'd suggest you, as a next step, come to HTTP BIS and give a presentation. It's come up there before in the past. I have to dig around and find out what happened, but I think it just didn't get quite enough energy. I think, getting involvement from CDNs and from reverse proxy vendors is probably what you want, and I think it's probably best to do it there, or get those folks there. And I think the tricky bits of this are probably in that HTTP is a hop-by-hop protocol, and you have to account for that in the design of the header and so forth and so on. So at least involving that community a little bit would probably be the next step.
That makes a lot of sense. The point about hop by hop, this was very much, at least initially, designed to only account for sort of the client to origin connection as a single piece of sort of, I don't even know what to call it, not allowing for this sort of information to be conveyed hop by hop. But that said, it's certainly the sort of thing I would want to discuss further and make sure I really had a handle on going forward. So with that respect, going to HTTP BIS seems like it makes sense.
Hey, Ecker?
Yeah, Eric Piscola. I certainly agree this is an important application. We don't have as much TLS client auth as we'd like, but we do have some, and that's going to help. Maybe now that we fixed the privacy problem, we'll get more. I think I'm the person with the technical feedback. I think getting this right is substantially more subtle than this draft sort of reflects. So probably we need to like actually think about it a little harder. I agree with them, not that HTTP is the place for that, though. So some of my comments apply were sort of TLS comments, so it probably requires a fair amount of coordination with TLS as well.
Mohit Sethi.
Hi. So I kind of agree and support that something like this is needed. I was wondering, like, why do you need to send the whole certificate from the gateway to the application server, and why isn't just sending the subject identity enough?
I mean, the first answer to that is I've had people, the people that are interested in only the subject identifier, some are interested only in the public key, some are interested in the issuer and the subject identifier, some, like Eric, who just spoke, suggested that in fact the entire certificate chain is necessary. So there are different needs for different backend applications, depending both on what their functionality is, as well as what the sort of the trust model is, who's expected to validate what. At the initial attempt at this, which is the draft, even though it's in a 02, it's really pretty much a first draft of everything. My goal was to get to sort of something that would be widely applicable and easy to deal with, and the entire end entity certificate made a lot of sense to me in that context, because you wouldn't have to try to pick and choose at the standard level what particular pieces of data are relevant to the backend application. But that doesn't mean that that's the final or the right answer, but that was my thinking at the time.
All right, understood. I think this is worth pursuing somewhere. I guess I'll let the chairs and the ADs decide where is the right venue. Thanks.
Thank you. Next up, Joe Salloway.
Hi, Joe Salloway. Over the years, I've seen a number of kind of cases where this type of thing has been misconfigured, where the appropriate kind of removal of incoming headers has not been done at in the sense, the gateway that does the authentication, and in some cases, lets these headers through and causes all sorts of problems. Spoofing and things like that in the back end. I think having a standard sort of extension for this would improve the testability for these sorts of problems. So I'd be in favor of having a standard. And if we could also do things in that standard that would prevent some of that spoofing, that would be awesome too, but it might be a harder problem. But certainly having the standard would make it easier to test for this thing, because right now everybody's got different headers and you have to go know exactly what they're implementing in order to test that.
Yeah, I tend to agree with you. I think the standard likely and hopefully makes that situation better. Although I know there's, the counter argument there is it also makes it maybe easier for attackers to know where to start guessing and probe for areas that are misconfigured. But I think on a whole, having a standard for it and maybe taking it out of the range of configuration, but something that's just a functional checkbox piece in software that does the sanitization automatically rather than being an additional part of configuration likely improves the situation. So it's a funny way of saying, yes, thank you, I agree with you, but it is maybe subtle.
Okay, and last up is Michael Richardson with 2 minutes to go, and thanks everyone for keeping your questions tight.
I guess I'll just relay what I think I was going to say, respond to Mike Bishop's thing. We need more than what he suggested. And quite a few people in the Jabber said about 77 different things. And then the most interesting part was the suggestion that we actually need a working group on back-end stuff, and that should be split out of HTTP. That actually sounds like I wouldn't have thought we needed that much, but if that's the right direction, then maybe that's the right way to go.
Okay, do our ADs have anything to add?
So the primary thing I've heard is there's positive feedback across the board that we need to look into this a little bit, that we need to think harder about the venue. I think further, based on the feedback, overwhelmingly there's kind of talk about we need to at least talk to HTTP BIS about that. and we probably also want to make sure that there's adequate coordination kind of with TLS. So my suggestion, Ben, jump in if you disagree, is that we get a conversation started in HTTP. This maybe we can get on the agenda in an upcoming kind of virtual interim, and if we need something broader, as was just brought from the Jabber channel, we can talk about that. So HTTP this.
This sounds great. So if there is no objection, wait 30 seconds. Maybe even only 10. Then we can move on to the next presentation. Thank you, Brian.
Oh, thank you very much.
So next is Kirsty.
Give me 1 sec, I'll get the share going. All right, there you go.
We cannot hear you. You seem to be connected via phone. And that, I don't know if it's a problem if the Secretariat muted everybody.
Try *6.
Maybe this, if the Secretariat could try to unmute Kirsty P. as a host. Yeah, I'm not the host, so I cannot do that. Let me contact them.
Yes, Secretariat is online and trying to unmute, but is unfortunately not able to. We're looking into this right now.
Okay.
So perhaps we could move forward to our last presenter while we get the audio issues sorted out. Rick, would that be okay with you?
Sure.
Sure. Give me 1 second. I'll get the slides switched around. All right, there you go.
Thanks. My name is Rick van Rijn, and over the past few years I've been working on a puzzle that NLNet, an open source funder, has been posing towards me, saying basically that the internet is sort of centralizing into silos and people are not getting the distributed experience that they really should have according to, well, how we felt the internet should behave. What we came up with is that it's basically the hosting providers that are not picking up developments as fast as the few silos are, and that anything that empowers those people is good, and is going to help distribute responsibilities and power over the internet. So what I have been doing over the past few years is designing an identity system, which basically says we start with a domain and clients should have a web host that have lightweight identity management solution that allows them to basically access services everywhere, hopefully, where they can bring their own identity. And the identity will be me at mydomain.com, Joe at example.com. And we've been designing on that for quite a while, and I'm here to present basically the idea. The client in this case has an account with an identity provider that runs at their different web host, and they will run up to the purple foreign server and they want to authenticate as someone, and the foreign server jumps back at the identity provider for the domain. And because it's an identity at the domain, they can basically trust whatever client identity is given there. I've been looking for a number of protocols to do that. And there are a few very, very interesting proposals, I think, that we can make now. And I'm here to present one part of it. But basically, the concept is to bring your own identity, and that means that you need to have some form of realm crossover. The foreign server can have a way of trusting the client realm. And I hear people talking through this. I'm going to ignore.
Pardon, I was just testing the audio, pardon.
And a backend protocol for doing that might, for example, be Diameter. Now, what protocol can we use to authenticate? Because it will be, there are many proposals to making a single sign-on system that's specific to the web. But as far as I'm concerned, that's a little bit too easy. There are so many other rich protocols that we should have and should allow clients to use. So I think comparing what a mechanism would be suitable for all the protocols, or virtually all the protocols. Can I have the next slide? Can I have the next slide, please? That's a yes. Three mechanisms came up, basically. SAML, which is can be very heavyweight with all the public keys and all the refined semantics of verifying it. Well, the first speaker spoke about this actually quite in a lot of detail. So it would be a possibility, but it's probably too heavy to get people on board with very easily, especially when the which end users with small domain hosting solution. Kerberos might work, just like you can have Kerberos in a centralized in a organization. You can have Kerberos at your domain host. There are no strict problems with that, except perhaps that some people find it offensive to have to log on with Kerberos every day. I mean, some people are really accustomed to the passwords and don't want to break habits. So the third option, SASL, actually gives a large range of choice. We can go from the easy access with a password and gradually grow to Kerberos. The nice thing is you get to grow at your own pace. And if it's a SASL client that's run by the end user and the SASL validation service run at their IDP, then what you're having is a free choice to have a local policy for your domain and say, I only want to do Kerberos, or I only want to do Scram, or and maybe I just want to do plain authentication. You get a lot of choice. And because the foreign server is not really involved in the actual authentication in this design, that's actually, they can't pull you down, basically. They can't say, we only support this or that. Now, this requires a few crossover mechanisms. And for Kerberos, I've found a way to do that. And for SASL, I've found a way to do that. So to pass the authentication through the intermediate server who can then rely on the result from the home IDP. Because SASL can carry the two other options, basically, I think that's the winner solution, except on HTTP, where there is no embedding for SASL. There has been work on that 15 or 25 years ago, 15, I think. And that never got around, but that was before HTTP authentication was more clearly defined. And the things it ran into, I've looked into those, and those are gone in the current proposal. So what I'm basically proposing is let's add SASL to HTTP so we can have these benefits of realm crossover for virtually all the protocols, so that because HTTP runs along with the other protocols, or at least can run along with the other protocols with a pluggable authentication system. Can I have the next slide, please? So this is a bit crowded, I'm afraid. On the left, HTTP SASL, very briefly. I don't care so much about the how, I think that's all in the draft. I would like to explain why what's useful. But the request basically contains a SASL token that's being sent. It mentions a realm so that the intermediate server knows where to look back through Diameter or something to look up for a yes or no for the authentication. And basically, the first time around, it will select a mechanism. These are just tokens that are passed along the authentication header. And the HTTP server will respond with a SESL authentication header containing a server-to-client SESL token. It might relay back server-to-server state. This was one of the things that went wrong in the previous proposal because that hadn't been hardened out yet, that HTTP wanted to have such a stateless performance. But since HTTP servers essentially want to be stateless, there's the intermediate state that the SESL steps require that needs to be stored into a protected token and a pass back to the client, which then relays back in the following request. And that can iterate as long as it requires until it finally gets a yes or no. And then basically it can continue. There's some provisioning for caching so that you don't have to go through this interaction for every single resource you're addressing. That's just an extension, basically. On the right, I've drawn what this means in terms of realm crossover. So we have the client here, which is a lovely lady. No, somebody with a skirt, I should say. Let's be modern. And this client issues a SESL authentication, and it selects the mechanism called SXOver, SESL crossover. And it mentions the realm where it wants to do that. The SXOver basically is encrypted by a key that the user shares with their realm. So it's end-to-end encryption. And the only thing the purple server can do is look up the realm, find the backend, make diameter connection, and pass on the SXOver request. And then pass back and forth whatever the client sends or what the IDP sends back until the client is authenticated. The foreign server sees this traffic pass through. He knows that eventually it's a very validated realm. I mean, you can have DNS and DANE and TLS. All those things are quite helpful. And certificates, of course, are quite helpful to establish the validity of the realm. And anything at that realm is then reliable. So when this contacted validated realm says that it's Mary, for example, then the purple server will know that it's Mary at realm and can proceed acting with Mary at realm without having ever seen Mary before or without having stored a password. So there's no theft of passwords needed anymore either. So this is how the SESL crossover mechanism works. There's one added thing that's definitely something to work out in more detail, to explain in more detail. I don't think I've done that sufficiently in the draft. But channel binding can actually be used in the form of end-to-end authentication in this. So SXOver is always a mechanism, a SESL mechanism with channel binding. And that means that Mary knows that she's talking, because of the key she uses, Mary knows that she's talking to the IDP, but the IDP also knows it's done for a particular connection. It's not passed through an extra intermediate server that might be, a couple of attacks are possible there. They can be mitigated if this is done well. Next slide, please. This is the other way of doing realm crossover. That's based on Kerberos. This all, by the way, pieces of this, the essential pieces have all been implemented, except that it hasn't been brought together to one whole yet. But basically, we know that this works, all these mechanisms. Here, the client on left on top wants to contact a service in another realm. And basically, what the client has is a host name. So the client runs up to their own KDC and says, I would like to have that particular service for that particular host name. The local KDC goes and looks into the database. That's the 1.1 arrow. And the database says, I don't know that host name. So what the KDC then does is it looks into DNS using DNSSEC for certainty to look up the realm for the the realm for the remote area, and then looks up the KDC. Then the two KDCs, the client KDC and the service KDC, engage in a key exchange, which is basically a TLS connection with standardized messages going back and forth. And at that point, there is a shared key between the two KDCs. This is standard facility in Kerberos, except that normally it's done by hand, and in this case it can be a key that's automatically deleted after a month, for example. You could use it for a month, and it might be refreshed in time, for example, if the key is used a lot. But basically, the two KDCs now know about each other, where one is the client and the other is the server. This key can now be used to construct a reference, a redirection that's sent back to the client. That's the two-dot-reader arrow going back to the client. And that's a standard shape that all the Kerberos software basically understands how to interpret. So the client software doesn't have to change to accommodate this. Only the KDCs need to support this extra protocol and these extra lookups. The client now has a way to contact the ticket granting service for the service KDC, so asks once again for the ticket, but to another place. And because this service KDC is aware of the service host name, it can actually grant a ticket, and then the client can finally run up to the service and say, hello, it's me, shall we please engage in communication? This works with standard Kerberos clients as they are today. It's only an extension to KDC. It's, well, key exchange on the fly when it's needed. It uses DNSSEC, DANE, and TLS as the basic security foundation. And the one thing that's really important is that the keys that are being exchanged between the KDCs are symmetric keys. So once you know them, you can unravel the entire derived keying system. So it's vitally important that the key exchange is done with a quantum cryptographic, a quantum-proof mechanism. And especially the key exchange is a scary bit, of course, because DV-Helmet doesn't really have an alternative yet. That's quantum-proof, as far as I know. So this definitely is a puzzle, but there are other systems. I think lattices, for example, might be used. We'll need to see what's standardized on TLS, but this really requires quantum-proof TLS between these two KDCs. But that will come at some point. So this is basically the thing I wanted to present. So there's HTTP SASL, which I think is an enabler to have the same authentication mechanism for just about any protocol. It can include the other two versions that I presented as other alternatives. And there are, this can help to unleash realm crossover in two different ways, which I think is really helpful in getting clients more control over their online presence, their online identity, and aliases and pseudonyms and all that can certainly become possible. So I believe this is useful work. These are actually three different aspects of the design. So I'm always looking for how to present this, where to present this, how to put this up, because the specs are concentrated. They describe a single thing. I don't know exactly what the best path is to bring this into the IETF and where to bring it in. HTTP BIS has responded, but has been a lukewarm response. So I thought I should also come here and talk to some people involved in security about what they felt about this design. That's what I wanted to say. If there are questions, please.
Yes, so just to remind everybody that this work has already been dispatched to HTTP BIS.
Has it?
That's what I've heard.
No, that's not what I meant to say.
Okay.
So I see Mark Nottingham is in the queue. Perhaps we should let him comment on this.
Go ahead, Mark.
So we had a discussion, Rick had brought it up to HTTP BIS and to dispatch and to Secdispatch. And so we had a discussion with the dispatch chairs about what they should do. And we came to the conclusion that the best thing to do would be for Rick to come to the next HTTP BIS meeting, whenever that might be, and give a presentation to that community. And so we've scheduled that. That should be whenever the next time is. I got on the queue to say we've done that, so we're expecting to see this again in HTTP BIS. But generally, our criteria for adopting new work in HTTP BIS is that there's implementer interest and a good set of people who are willing to review and contribute as always. As Rick said, the initial response was lukewarm. Once we have a bit more discussion, we'll see how that goes.
And that's, of course, why I also brought it up here, but I already explained it all.
All right, so with all that established, do folks have clarifying questions, questions or comments on this work?
Roman, this is Roman speaking. I want to jump in as AD. Back to kind of what Mark said, the criteria of having implementers and kind of interest is something we also have in security. So I'm equally interested in hearing if there is that class of interest to also help us decide what to do next.
The Jabber chat is still going, but I don't see anybody coming to the microphone.
I don't think you.
Okay, I then ask a question. When you say implementer interest, we are of course implementing this. We are talking to hosting parties who want to use this, but are you specifically talking about HTTP service implementers?
For HTTP-BIS, we usually look at the different parts of the HTTP ecosystem, so server implementers, intermediaries, browsers, CDNs, those sorts of folks.
Yep.
It gets a little more tricky, I might say. If it's just a server-side component, then if people want to, do things server-side, like add headers or, facilities that can do just by extending a server using CGI or whatever facility, that's one thing. But if it requires server-client coordination, then we need to see we generally like to see the breadth of interest across the different components that need to implement.
Yeah, and that is the case here, of course. Yeah.
Okay, Ben Kaduk is in the queue. You're up.
See if I can successfully unmute. This is Ben Kaduk. You hear me?
Yeah.
Yes.
Okay, I had some severe technical difficulties out here, so I missed one of the talks. But I just wanted to point out that some of the discussion in the Jabber room has been sort of centering on whether authentication happens at the HTTP layer versus the application layer, and how the user experience is not great. And I just wanted to sort of emphasize, so the user experience is not great in like the current HTTP basic auth, that sort of thing, and for negotiate as well, for that matter. And so sort of some of the considerations in that area about how can we design something that will actually be usable seem relevant to whether or not this work is going to succeed. And I'm sure I did a terrible job of summarizing the Jabber room, but I welcome other people to chime in as well.
Yeah, if I may respond to that, the most scary thing to me is to use credentials in the same space where JavaScript code is running, loaded from dynamic places, including advertisements that have key logging capabilities. I very much try to get away from, in these designs, I very much try to get away from applications performing authentication. And I know that's not everybody's approach, but I would really like to push it into a lower layer. Also, this is reasoning specifically from HTTP. What I'm trying to get to is that I would very much like to have the same authentication mechanism across all the protocols. Because I see a lot of, it's almost like a Red Sea every now and then. There's web authentication and there's authentication for all the other protocols, which somehow hardly ever meet. And that really surprises me and is, I think, a very unpractical situation.
We got Ecker in the queue.
Yeah, and I think that so you said web authentication. I'm not sure if you mean WebAuthn or you mean authentication on the web. And I think Oh, that wasn't me. I mean, I think that as Ben was sort of alluding to, though perhaps we don't quite agree in the details, the underlying story with authentication on the web, as far as I can tell, is the sites don't want to don't want to like defer to the browser any of the authentication primitives. And so that sort of means you're stuck with either something which is like essentially, web forms, or which is cat-like typing detected. Which either like web forms or something transparent like WebAuthn, on things that are HTTP but not web that are applications. And obviously there's like a lot of alternatives for like having things like controlling the for other modalities. And that's why we've seen a lot of interest, for instance, in like PAKE protocols for TLS and non-web applications, but not so much for web applications, because we can't figure out how to like get people to do like the PAKE for web operationally. So I don't know how helpful it is, but that's the context.
Okay. I think that we are out of time now for this presentation. Thank you, Rick.
Thank you.
And we can move on to the next. So, Kirsty.
Hi, can you hear me now?
Yes, we can hear you.
Thank you so much.
Sorry, give me 1 second to get the slides up. All right, off you go.
Thank you. So good evening, good morning, good afternoon, everybody. I'm Kirsty Payne from the UK National Cybersecurity Centre, the NCSC. Just for background, we're a government organisation that's aiming to make the UK the safest place to live and work online. I'd just like to take the opportunity to thank the chairs and the IETF Secretariat and everyone who just popped up to help me with my mic issues, and those who are dialing in from a range of time zones at the end of a long week, or maybe even actually your Saturday morning. So I hope you're all well wherever you are and whatever your circumstances. I'm here to talk about my first IETF draft, which, as you can see on the slide, is Draft Pane Smart Indicators of Compromise, which I hope will be a useful reference or insight to some engineers who perhaps aren't too familiar with the cyber defense, attack defense industry. So I'd like to get feedback on this draft and gauge some interest, and maybe as a stretch goal, perhaps find a venue for this draft now or in the future. So next slide, please. Thank you. So where you can find the draft, it's been co-authored by Ollie Whitehouse of NCC Group and myself. You can find it on the data tracker, the link's there. You can also find it on GitHub. And I've already had some feedback, so please keep it coming, especially from a range of people. Those who are familiar and those who are not familiar with the topic. It's really good to get that breadth range of views and stakeholders in all standards work, and of course this is no different. So I'll just say at this point, before I talk about IOCs, or indicators of compromise, I'd just like to briefly outline what they are so that you're not lost through this whole presentation. IOCs are features or features or artifacts of attacks or attackers. That's just a very sort of high-level view, and we'll dive into that through the presentation. Next slide, please. So here's the motivation for why I'm bringing this draft here. Firstly, both Ollie and myself, we'd like to share knowledge with protocol engineers on a commonly used and important technique in cyber defense or attack defense. And just a note here, because I'll use these terms interchangeably as they mean the same thing to me, but I understand one is more IETF palatable, so that's why I'll use both throughout the presentation, and I think in the draft as well. So anyway, it's, to share knowledge with protocol engineers. And to my second point, this knowledge share should, I hope, prevent this technique being accidentally ignored. So engineers can make protocol design choices that affect the availability of IOCs, which are those artifacts you observe about an attacker. And so both Ollie and I, we'd like the IETF community at large to consider the impact of this IOC availability, just in either direction, if they're more or less available, the related impact that can have. So for an example, for those of you who are familiar with MITRE's attack framework, there's quite a lot of momentum in the industry at the moment about this. It's a useful framework that helps categorize and classify attackers based on how they act in a victim's network. And the framework is massive. It's really, really good. But just to take an example, if you drill into one of the techniques like data encoding, you'll see it lists the number of techniques that can be associated with an actor or a group of actors. And it's only possible to be able to do that and defend against the group of actors if security teams or whoever have the ability to get that information from the protocols. And there's also a number of rules in Sigma that rely on there being sufficient things in protocols to form IOCs as well. And so finally, to my third point on the slide, which is that this draft can, and it already has, brought a bit more cyber defense expertise into the IETF and engaged folks from that industry who weren't previously engaged. And so I think that's just a good side benefit for the IETF community at large. Next slide, please. Thank you. So this is taken straight from the draft. It's the abstract as an introduction. So to be clear what this draft is not, it's not defining a protocol, it's not a format for IOC sharing, it's not a threat feed format or anything like that. This is describing an important technique in attack defense for reference and for information. So the draft, as it goes through, it outlines different types of IOCs. It discusses their effective use, their limitations, their benefits. Some IOCs are directly relevant to the work of the IETF, and those are what we call like protocol artifacts. But importantly, we're not presupposing, as it says in the draft abstract, where you would find IOCs or detect them in the first place. It's just that engineers should be aware that they need to be detectable to fulfill the functions described in the draft. Next slide, please. Thank you. So I love a good table of contents, and I hope you do too, because that's this slide. This draft is aiming to describe and illustrate purposes of IOCs, which are widely used. So the way it's structured is that first it goes through what IOCs are, and then the benefits of them. You can see there are 7 sections there. Then we introduce the pyramid of pain, and I've had quite a lot of jokes about this, but no, sadly, it's not named after me. This is not something I created. It's often referenced in the cybersecurity community, so I sort of wish I had invented it actually, but I didn't. And it's just there to show the broad properties, the broad range of defences that IOCs can provide. And then you'll see as section 5, we relate that to defence in depth. And then finally talk about a real threat group, APT 33, for which some IOCs were identified and used for defence, just to give a case study to contextualise what's going on. Next slide, please. So what are IOCs? Well, here's a list of them. This is taken from the draft as well. Clearly, they include some protocol relevant things, and that's what's relevant and the link to IETF. But there's other things in there too, like hashes of malicious binaries or scripts. But you'll see IP addresses, domain names, TLS SNI values, and certificate information. And so there's a section in the draft that talks about why IOCs are just great, and I'll go through those briefly, because I think it's important to recognise the benefits that IOCs will bring. The first is that they are just a big win for the underdog. So it's cheap and achievable for lots of organisations, so for charities, for small companies, for schools. Like if you're a small manufacturing subcontractor, perhaps you're in the supply chain for a big manufacturer, you have quite a big threat attached to you. Perhaps you just don't have much resource to manage that risk. However, you will likely have a firewall, and so you can use things like these IOCs pretty easily and still get quite a good base level of defense there. IOCs are just made for network defenders, for regular sysadmins. So they're not all government departments or big tech companies. And because of this, they have a widespread and huge multiplier effort on attack defense effort. So they are just have this big multiplier effect, which is really useful. IOCs are very shareable, and some of you may be aware of methods in which you can share IOCs at the moment. But this is just about the shareability and reproducibility of IOCs being really quite top-notch. You can just capture it and keep doing it, consistently look for things and automate that. And it allows, again, the underdog to benefit from resources of bigger players. So through this shareability, you're sort of protecting a whole community and permitting this cybersecurity like uplift, which is great. They can also help with attribution, which means that an organisation can sort of prioritise or perhaps accept some false positive trade-offs when they're looking at a particular subset of malicious actors. And that gives organizations this kind of technical freedom and capability to choose their own risk posture and defense methods. You also have big time savings with IOCs, so it avoids duplicating your investigative effort by conducting the same investigation in separate organizations just to find the same IOC because of that shareability effect. And when you get automatic deployment of IOCs working well, then you get blanket protection, but with minimal human intervention and minimal effort, which is kind of like a cyber defense stream, so it's pretty good. And for an example, like we have where an email campaign might be happening, you can monitor for attacks, you can discover IOCs, and you can get them out through your blanket DNS protections, and you're in this like sweet position where the same email campaign is mitigated before someone else even clicks the link, and so you kind of protect everyone like for free nearly immediately, which is pretty cool. And of course, there are other automated techniques like machine learning, and they do have their place, but compared to IOCs, these are a different technique really. They're generally more expensive and can require manual intervention. You might have more false positives or a lower confidence in each event, which can require sort of manual investigation, whereas IOCs kind of require little to no human intervention. They do provide this protection against known threats. You can also use IOCs to investigate and discover previous attacks, like trawling through logs, and they allow for defense in depth. So you have this common question of like, oh, but you'd install antivirus or AV. And yeah, it's all very well saying deploy AV, and of course it is the first and it's an important port of call, but just to be realistic, like not everything will have it. There's another draft within the IETF data tracker at the moment called CLESS, C-L-E-S-S, which is the capabilities and limitations of endpoint security solutions. And that has quite a catalogue of various reasons that things might not have AV or might not be up to date, like IoT and legacy equipment. And even if something does have antivirus, of course, that can fail for very good reasons. Perhaps it's going for a low false positive rate, or perhaps it's a never before seen executable. There's plenty of good reasons. So rather than just relying only on AV, we aim for a sort of layered defense in depth. Can I get the next slide, please? Thank you. So this is the pyramid of pain, which is often referenced. Just to note that TTP is at the top. That stands for tactics, techniques, and procedures that you might see associated with an attacker group. And I got asked, why is this a pyramid, not a list? And it's not just because this ASCII art was super fun. It's this kind of building, the idea that you're building on artifacts below it. So it's quite hard to start at TTPs and work down. You sort of start from the ground up. So every layer has value. But as you'll see from the axis on the right-hand side, that they vary in pain and fragility and precision. So the first kind of thing to talk about is how much pain there is associated with these IOCs. And it's actually not related to like pain of deployment or anything like that. It's how much pain it is to an adversary if you defend at that point. And so it will vary from recompiling to totally losing your persistence. And it correlates to how much pain it is for an adversary to change that. So for changing a hash value, like I said, it's just recompiling. It's not too difficult. To change your IP addresses, like a bit more difficult. And so it goes right up to changing your entire tactic and your techniques and the way that you infiltrate. That is much, much harder. And of course, with how much pain it is to change it, that's correlated with fragility. So the easier it is to change, then the more fragile that IOC is. Again, taking the example of hash values, because that's quite a common and easy one to understand. It's very easy to change a hash. Once you've changed it, that IOC is totally fragile. It's gone, it's changed. And that is also correlated a bit with precision. So more precise is, obviously better, but it's usually linked to fragility as well. Using that hash example, you get no false positives, but it's easy to change. So the idea of IOCs is that you can use a range of these things, and you can meet in the middle somewhere. So wherever works for you, to give high confidence events just specific to your deployment case. And that's the idea of the pyramid. So to kind of tell a story with this, like if a compromise happens, then as we said, AV is your first and important port of call. But then, it could be absent if you have like hard to update infrastructure or some other reasons that are mentioned in class. So then you'd go up this pyramid and you've got IPs next and access control lists, which can go on firewalls and or a DNS filtering service on domain names. And that would blanket defend kind of all your endpoints, but of course it comes with false positives. So the idea is that you can employ a range of these things just depending on your risk posture. So to illustrate that in the draft, we discussed like a real case study APT 33. It's not a comprehensive study of that. It's intended to be read alongside open source material. So this is where IOCs were used to defend against an advanced threat. Now, there are many, many more case studies available, and I'd appreciate contributions or ideas for those, but if they add some other nuance, like I wouldn't want the draft to kind of bloat into a big list of all the other possible case studies and all the times that IOCs were used, because that would be absolutely massive. But just for APT 33, we focused on IOCs compromise 9 fragile indicators, like hashes or email subject lines, 5 IP addresses, and 7 domains. And as you can see from this pyramid, like they vary between levels. Next slide, please. Thank you. So I'm looking for input. I've already shared the draft with a few people and had some feedback and comments so far. So thank you to everyone who has read the draft and commented. So far, these seem to indicate that this is like useful work or helpful or informational in some way. And that's come from a variety of people with a variety of backgrounds. So that's quite encouraging to me. Suggested venues have so far included Mile and Sackham. Had a comment that didn't seem to fit into any present venue at the moment. And actually today, a couple of questions were posted on the smart list. So I'll just kind of address those and then go to open mic if that's okay. So one question asked today was like, what's the benefit of publishing this as an RFC? And so my view is that some IOCs are directly relevant to the work of the IETF, like those ones that I listed before that are protocol artifacts. So I'd just like to make this information like available where it's relevant.
I'm sorry, Christy, could you scroll back? I lost that 30 seconds of why it was good for an RFC.
Oh, okay. Yeah, so what's the benefit of publishing this as an RFC? Yeah. So, yeah, some IOCs are just directly relevant to the work of the IETF, so those that are protocol artifacts. So I think it's kind of good to make relevant information about those kind of IOCs available to those who need it or who want to have it. And whilst there's kind of like, I think having something succinct and clear and public is useful anyway, rather than kind of trawling textbooks and blogs and kind of putting this together. But for me, the particular benefit for an RFC comes from, like, one, making this available in a format that's familiar to protocol engineers, because we're quite happy and familiar with an RFC format, and two, kind of making it available in a venue where people might reasonably see it without additional effort on their part. So the audience is kind of protocol engineers, those in the community that are involved in security, and just to consider this like availability of IOCs where it relates to protocols. And I think like separately having a reference to kind of point to whenever discussing or writing about this topic, I think that could be valuable. And then just separately, like, IETF, it has in some places it's like a very collaborative venue to create a document, and you can get a broad range of experts and expertise commenting on a draft. So I think it's kind of valuable for that. And then there were another 2 questions on the smart list that were dispatch relevant, so I'll just answer those and then wrap up. So the first was if the draft would remain a summary draft, and if so, would it fit into Mile? So I'm not a Mile chair, but I don't know about that second part. But essentially, I can see the draft like evolving with input from others. So this leads to the second question, which is, would the draft evolve to state applicability to IETF protocols, with new thoughts on how IOCs may be used? So I think, yeah, it could be like both 1 and 2. Like I would like authors to join me and Ollie. I'd welcome like development by people who know the industry, who know what's protocol relevant. I could see it remaining as a summary draft, in which case like perhaps Mile fits, I don't know. But I think if collaborators think it would be more useful to evolve and state like applicability to protocols, perhaps that's how this draft moves forward. Perhaps new ideas on how IOCs can be used would be like an enhanced direction for it. And if that's the case, like I'm also not sure where such a draft would end up, but I guess that would depend on the results of the draft, or perhaps there are views in the room already about like what that would do. So at this point, I'll stop talking because I don't normally talk for this long in one go. But I'm keen to hear from those who are attending here, like if you're interested, if you've read the draft, if you have any feedback, or if you'd be willing to work on the documents with me, or just to hear your questions if you have questions from this talk. So thank you very much, and yeah, over to the chair.
So I put myself, I guess, right before you, Ben, in queue. I hope that's okay. my question would be to see if you plan to evolve this beyond a summary, if there's some way that through, something, if it were to go to MILE, could it be expanded to how might you integrate it into protocols, or even OPSEC? How might you put IOCs or integrate them in new ways so that they're relevant to the working groups and also relevant to changes in documents that warrant an RFC publication through the IETF stream as opposed to ISC, the independent stream?
Yeah, so I think that kind of depends on. Yeah, thank you for the question. I think it depends on like collaboration and what direction we think the draft would be helpful to go in. I think it could definitely become a lot more specific and a lot more tied to certain protocols. But I'm not sure, like, the independent stream, if that's like a less direct, or it can be a more general document in that stream. But I think it's kind of like what would be a useful informational reference, I suppose. So at the moment, the feedback I've had is that it's quite a good like summary, and that there's definitely space to go into more specifics. But this is just a 0-0 draft, so it's kind of like just putting it out there. I've had no one so far say like they already knew everything in it, which is like nice. So I think it would be good to like maybe just see maybe I'll get views from the rest of the people in the queue, but also, yeah, I could definitely see it going a bit more like applicable to certain protocols if that's the direction that we think would be helpful.
Okay, Ben Kaduk, and thank you, Christy.
Hi, this is Ben Kaduk. So I was sort of following up on Kathleen, who did a great job setting the stage. I think there's probably several different directions that this could go in, and it's not really clear to me which one is the best. And by directions, I mean like the actual document itself, in addition to a home for potential publication. And so like if we did want to frame it in terms of this is a sort of information that we might want to convey in a protocol, such as MILE or IODEF work, that would be one approach, but it would also be possible to sort of just frame this as a sort of introduction or maybe tutorial style document about this is a set of concepts and techniques that are used by security practitioners, and give a little bit of insight as to how that can interplay with IETF protocols. That would be one aspect. You could also drop the potential for interplay with IETF protocols and have it be a more standalone thing. So I feel like we would need some input from people who are willing to put time in to help shape the document towards targeting one of those and being more familiar feeling or readable to generic IETF participants in order to find a good home for this in IETF. If we don't have as many volunteers to do that, then it's not clear that there's a good place for us to publish it as opposed to, say, the ISE or some external venue.
All right. Thank you, Ben. And we have Rich from Jabber.
So I'm not sure that we have our job describer here, but his question was, is the interest in IETF because it will help the IETF or because the IETF has good rep for publishing?
Oh, so
sorry,
go ahead.
It has, what was the last bit? It has a good something for publishing?
A good rep for publishing, reputation.
Reputation.
Oh, does it? Oh, no, it's not the latter. I think it's notoriously difficult to bring new work into the IETF, so it's not a sort of easy avenue. I think it's just that this is kind of maybe well known in other organisations, and so it's kind of the idea is to bring it where it would be useful. So yeah, I think it's definitely more the former.
Thank you, and Mark McFadden.
Thanks. As far as the existential question goes, I think we do this. We do publish informational documents that are about operational experience and bring that operational experience to bear on protocol design. A relatively recent document that comes to mind is 8517, right, which is about the effect of middle boxes on transports. So this is something that we do as a community, and I would certainly support this going forward. I agree with the sort of general comment here about how the document evolves will determine where it goes. But as it's currently sort of outlined, it really seems like OPSEC might be a good place for it to try to answer the dispatch question, or at least that could be the next, the next best home for it in a way. But my first question, one of the questions that Kirsty brought up was, well, one of the comments has been, should this even be an RFC? And I reflected on that and sort of thought, well, we do produce documents that provide information about operational experience. And that's what this is in my mind. This is guidance to protocol designers about current operational experience. And so that's one of the reasons I support it. And if I were asked the dispatch question, I'd think about OPSEC first. Thanks.
Thank you. Roman, to you.
Looking for the double mute. Yeah, I wanted to make a couple of comments. I was going to say OPSEC is a possibility that was just mentioned, thanks. The other one is MILE, to kind of be more precise about how this could fit into MILE. It occurs to me that there's a particular architecture that MILE has with IOCs. There's a particular workflow being suggested about how they're used. Could we marry up the proposed workflow that's being proposed with using IOCs with some of the IETF technology in MILE? And then the last one to mention, this was teed up in the Jabber session about privacy considerations. Could this be inverted a little bit to remind protocol designers that they expose features in their protocol, and so how can actors potentially use those features that they expose for more pervasive monitoring? So a couple of ways this could go.
Okay, and Ben Schwartz.
Hi, Ben Schwartz. Yeah, I want to highlight that point that I don't think the draft as currently structured could command IETF consensus because it runs into conflict with a lot of existing work in privacy and passive surveillance defenses. So I think that the document should, in its current form, could go forward as an independent submission, but if adopted, I think would probably, I predict, actually be substantially modified and end up looking quite different in order to reflect the consensus.
Hi, yeah, if I can just come back on the last couple of questions. So
go ahead.
Thank you. Yeah, so I hear the concerns, and just to restate, this is a 0-0 draft, so it's not definitely in its final form, of course. But I just maybe go back to my slide on the kind of motivation for this and the reasoning behind it, which is just it's an informational RFC. So like this is how things are used, and this is they have benefits, and this is a fact. So it's just to share knowledge with engineers really, and then just to prevent the technique being like accidentally ignored. So it's just designed choices that kind of affect the availability of IOCs, and so making no judgment on what those choices would be, or what would be best for whatever your use case and your stakeholders that you're thinking of. But yeah, so I hear the concern, but I'd just like to redirect kind of those questions back to the motivation point that I covered in my talk.
Okay, Alyssa Cooper.
Thanks, Alyssa Cooper. Just on that point, Kirsty, when you say prevent the techniques from being accidentally ignored, that kind of implies like some follow-on documents that would actually try to, for specific protocols, enforce the availability of these, right? Because just by publishing this document, it doesn't actually prevent the techniques from being ignored. You would want to do something that's normative in order for that to happen, right?
No, so I think that, it's very easy when you think some expertise isn't there or whatever, that you might just be quite forceful in pushing it through. I think my view is that it's better to have the information available. I don't think that this at all will precipitate a follow-on document. The document is kind of what I've written. What it's a complete, in my view, like what it will be, and it will evolve, of course, with contributions from other people. But yeah, it's not intended to be the start of any bigger thing. It's just this is just one technique that I really would like to share. It's an important technique in attack defense, and so that's kind of the idea of just this knowledge share.
Thanks.
Okay, and Echo?
Yeah, I share some of Ben Schwartz's concerns. I think the question really is it really worth trying to get like consensus on this document, or will it be just as well as an ISC document where it could say what you want to say and just hit the points you think are important, and you can still get feedback, but like there wouldn't be the effort of getting consensus. So I think that's the question I'd try to be working out.
Okay, question from Jabber.
So I'm just relaying a Jabber comment from Stephen Farrell. Sorry, I'm scrolling back. I believe he said that this sounds like an ideal candidate for the ISE.
Okay, and do our ADs want to say anything?
ADs, Roman, Ben. I think it was to you, Ben and Roman.
Sorry, having some comms issues. This is Roman speaking. Yeah, I think there's a broad number of kind of opportunities about how to take it. I would, and so there's folks have different opinions on what it could turn into. I think it's worth exploring some of those. I think it kind of comes down to where the authors might want to take it. And I would recommend, further community kind of discussion about how to appropriately tailor this and, and where to insert this, if at all, kind of into the IETF. I mean, there was a broad set of recommendations made here. So it's a 0-0 draft.
So where should this discussion happen would be the next question.
So I think the two working groups that were mentioned were MILE and OPSEC. It'd be worthwhile, I think, to have conversations with both of those to figure out. But I think the difference between those working groups, and again, it's a different approach, is, MILE's talking about a specific set of technologies, as I think we've talked about. OPSEC is about a generalized kind of set of practices. So which one of those do we want to pursue? And that, I think, affects which working group.
Right, yeah, I agree with Roman. I think it will be important or perhaps prudent to see what feedback we actually get on the document and how the document evolves as a result of the feedback from the people who are willing to put the energy in to give feedback. Because I think where this draft will succeed depends on who is putting energy into it and what direction they want it to go in. So I think my recommendation is to not immediately try to get it adopted by a working group, but to get some more feedback from the community and evolve the draft into a few more revisions. And I would not be opposed to having that discussion take place on SAG, but I'm also open to other suggestions for discussion forums.
Okay, that sounds fair to me. Richard, Kathleen, does that sound you? So I heard feedback on the document to be gathered in MILE and OPSEC mailing lists. I kind of dropped the SAG because I don't really know, was that a presentation suggestion or?
That was just for email discussion about the
email
draft.
Discussion, okay.
At least to send comments other than just the authors.
So CC SAG as well, or?
I mean, if there's going to be the two working groups already, that may be enough.
Okay, well, thank you for the feedback. Yeah, I'll start with MILE and OPSEC and then see how those conversations progress and maybe update SAG at some point in the future as well. That works.
Thank you.
Great. So we Thank you, Kirsty. So we have 1 minute left in our session, which is perfect. So I can give a short summary of the dispatch decision that were taken today. So for the SVT signature validation token, the decision was to, for the action point for the AD, to set up a mailing list and start a discussion there. And then following the discussion, possibly start a BOF. For the client certificate HTTP header, it was dispatched to the HTTPS working group. So start a discussion there, possibly consider working group focus on backend stuff. For adding SASL to HTTP, no actions were taken. This was already planned to have a discussion in HTTP-BIS. And finally, our last presentation was IOC and the role in attack defense. And the dispatch action is to gather feedback on the document in MILE and OPSEC mailing lists, a working group. I hope that sounds fair. And anybody who hasn't signed the blue sheet, please do go into the Etherpad and do so. And this is the end of the meeting. Thank you so much for joining. Thank you, our minute takers, and everybody for joining. And see you soon.
Bye, everyone. Thanks.
Thank you, everyone. Thank you, everyone.
Thank you all.